right. It seems like I might have mentioned this the other day. So 10 cloud types. Which of the 10 cloud types are most like fog? It has to be low level and flat. Stratus, exactly. Exactly. So fog is most like a stratus cloud. Remember that, just to remind you what the video said too, we have low-level clouds like stratus and cumulus and stratocumulus. Then we have middle-level clouds that have the word alto with them. And there's two of those, altocumulus, altostratus. Then we have three upper-level clouds. The cirrus are the highest, cirrostratus, and cirrocumulus. What are the two precipitating clouds? Nimbostratus and cumulonimbus. Okay. There's what? The hybrid cloud? Stratocumulus, yeah. Although I thought the video did a good job. My least favorite cloud is stratocumulus, because you're like, dude, is it flat or is it fluffy? You just said both, stratocumulus. I thought the video did a good job of kind of describing that a little better, so I think I can do that. Okay, so if you have fog, then basically your air is saturated. We know that because water is condensing. It's that little liquid water particles that makes it look hazy. Little liquid water particles. That's what a cloud is. So there are different ways to saturate the air, and actually this was a homework, or not homework, but the quiz question that you guys handed in. This was your quiz question. How do you saturate the air? You can either cool the air down, or you can, I was thinking like a turkey injector. You can inject your turkey with, you can inject the air with water vapor. Okay, those two things. So there's 4 types of fog, and they all have to kind of do differently with how they form. Okay, this radiation fog, this is actually, and if I could draw, I'll put a little smiley face here. This radiation fog is what kids hope for this.
Cancellation of school.
That's right. Or delay of school, yeah. They hope for this in the morning. Radiation fog is morning fog. Not all of the fogs happen in the morning. And they gets its name radiation. If you read the description, basically they're saying that if this is my Earth's surface, okay, one of the things that we said is during the daytime when the sun is out, the Earth gets nice and toasty. The Earth gets nice and toasty. Okay, as the Earth rotates and no longer has the sun shining on it, this is my, let's see what color, I'm going to pick purple. This oozing stuff, okay, that is the Earth cooling off. Okay, we call that radiation. The Earth is basically re-radiating the energy it got from the sun during the daytime. So with radiation fog, basically what happens is there's no clouds, like you see it's favored during no clouds, and what happens, here's my Earth again, and my radiation is up here, okay? And basically we have a cool region right here. The Earth it basically re-radiated all the energy it got during the daytime. So that cool pocket makes this radiation fog, okay? And I know in here somebody mentioned recently, if you go to bed at night and your dew point temperature when you go to bed is like 5 degrees below what your current temperature is, and the forecast is for it to get, 10 degrees colder overnight, you know that your air is going to reach the dew point temperature. And that could set you up for dew or frost or fog. Yeah. All right. So radiation fog. This is advection fog. Okay. The word advect actually is like, I think of it as a verb. And advect basically means to move, again, if I make this kind of my Earth's surface, advect means to basically move horizontally. So that little orange thing I've shown is that orange chunk advected. Okay. So advection fog. If you read this, basically it's talking about warm, moist air advecting, relocating over someplace that's cooler. So it's possible that your ocean is warm and your land is cooler. Okay, so it advects over, it cools down, and
You move off the land over into the ocean.
Actually, move off the ocean over into the land.
Oh, okay.
Yeah, it can go ahead and start and condense. Yeah. So, and they're showing it here. This actually probably is warmer water, cooler water.
So this is what I'm just trying to picture. I've seen this before in Lake Erie where the come off of it? Because like the snow front coming in was cooler and drops of moisture over top. Is that the same principle?
Yeah, it is the same principle.
Okay.
Very good, yep. I don't know if you heard him, he said he's seen it over Lake Erie.
Yeah.
Kind of this, yeah.
Okay.
This one, if you've seen movies of, sci-fi movie like The Fog, isn't there a movie out there? Yeah, okay. The Mist, yeah.
The Mist is totally different, come on.
Well, that's if you kind of live on the coast and you're kind of used to that sort of maybe I would have run right away. But seriously, yeah. So radiation fog, advection fog. Upslope fog is most like orographic lifting. That's one of my favorite ways to get a parcel of air moving up. Remember we talked about that before. Yeah. Orographic lifting. And if you remember what orographic lifting is, it's basically air slammed against a mountain, and the mountain does you're ready to go up.
Can't go through.
Not through, up and over. Yeah.
So it can't go through, it has to go somewhere.
It can't go through, it has to go somewhere, exactly. And so upslope fog is the same thing. It's quite possible. Have you ever seen I'm just thinking like of an aerial view of like a mountain. This is my mountain, that's awful. And along the side of the mountain you see, like here's my cloud. Okay, that actually is a chunk of air that's moved up, it's expanded, been forced to move up, and it's cooled down that's the lifting condensation level right there. The LCL, lifting condensation level. So
You see that with tall buildings too, correct?
I don't know. I haven't been in.
Like the skyscrapers,
Could be.
those down clouds come up over it.
It could be.
Okay.
Sounds pretty.
Hmm?
It sounds pretty. Sounds neat.
You've never seen the skyscraper with clouds around them?
No. I live a sheltered life. But my imagination can picture it, but I've never seen it. I've never seen pictures. I'll have to Google it. Sears Tower with clouds. I bet it's out there. And this one kind of goes back to Joe, what you were maybe talking about too. It's not Lake Erie, but actually even one of the Mississippi doesn't do it as well as maybe the Skunk River or some kind of more calm river. Have you ever seen it where it has like fog on top of it? Yeah, that's called actually steam fog. These three names are the same thing: steam fog, evaporation fog, and frontal fog. And these actually come from not cooling it down, but basically making it more moist. Okay, it could be from cooling down too. But basically, if you figure, we know water retains its heat longer.
Yeah.
Mm-hmm. And so it's basically above the water surface. If it's nice and toasty, basically you have if it's warm, you have liquid going to form vapor. So basically you've injected.
The temperature difference between the water and the air above is cooler.
Well, you've actually just changed the humidity. Basically, the relative humidity above the water is a lot higher because of all that, the liquid evaporating. Kind of localized.
Putting water vapor into it. Which
Right.
releases humidity.
Yeah, exactly. And that's in that when you run your shower in the bathroom, basically your bathroom is injected with water vapor too because of your nice warm shower.
That's relative to the temperature around the tub.
Right, but basically what you did was take a room that had normal humidity at normal temperatures. You jacked up the water vapor at the normal temperatures, and you saturated it with water vapor. And then this one is kind of like when I said if you ever go to Ventureland and they have black asphalt, that sort of thing.
Mm-hmm.
Basically, the only way this happens if it was nice and sunny. I mean, all of a sudden it had these kind of dropping rain. Yeah. And basically that is water that's being evaporated. Yeah. Too. So that has to do with hot pavement. So the 4 types of fog, they're great for some questions on your exam. Sometimes I have you list the 4 types of fog. Wouldn't that be a good question at the end? Maybe so. 4 types of fog. There's the radiation fog, the advection fog, upslope, and then 3 names. You get a pick. Okay, it can be frontal or evaporation or steam, but they're all 3 the same thing on that last slide. This is kind of where they occur. So, all right. So, dew versus frost. Again, they happen overnight, right? Both of them happen overnight. And if you've been doing your weather log, that's one of the columns you've been writing down is what is the dew point temperature right now. Basically, it's the temperature below our current temperature that you need to lower the air down to in order to reach saturation. Yeah. And depending upon if it's below freezing or above freezing, you'll get frost or dew, respectively. Yep. So, and maybe you've noticed this before, especially with frost, maybe, because dew you can't really see it, but frost is that milky white, right? If you pay attention, you can have like a tree here, big old tree, okay, kind of nice, and it's got grass underneath it though, okay, because that's important, right here, okay, and then over there is a clearing with the same grass. So it's quite possible that you come out in the morning and basically you'll see frost, 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 frost over there, but there'll be no frost under your tree. Because your tree actually didn't allow it to cool down to the frost point temperature. Why? Because basically it kind of acted like clouds act like. Basically your thermal energy, trapped it. It's like a nice, if you're a critter, you'd go sleep under a tree.
So it's that survival too.
Yeah.
Sleep under cover.
Yeah, exactly. Make use of that. Okay. Exactly. But then the other thing is, again with frost, it's inevitable that if it can, there'll be frost on your car in the morning, right? And for a similar reason, your car cools down just like that after you stop running it. Okay, so I think we used this word deposition before.
I think it goes from water vapor directly to a solid.
Exactly, when it goes from water vapor right to a solid, skips the liquid stage. That's called deposition, and that's what frost is. So do you guys remember this? So if it goes from a vapor to a solid, is energy, I'm going to say A or B, so is energy released or is energy required? How many people think that energy is released? That is correct. Very good. Energy would be required for it to go from a solid to a gas, or solid to a liquid, exactly. Which is sublimation. If it skips the liquid state, it goes directly from a solid to a gas. It's called sublimation. Very good. Okay. So I think this link will take me to the out on the internet, and let's see what the dew point temperature is. What do you think? You think we're expecting snow? What do you think? Is the humidity high or low?
Should be high.
Kind of high.
And then get precipitation.
Exactly. I think the humidity is kind of high. Do you think the current temperature, and the dew point temperature is down here, so do you think the dew point temperature is very close to the current temperature? Probably. Let's see. Let's take a peek. I think this one's AccuWeather. No, it's the Weather Channel, weather.com. I'm keeping an eye on this is my battery. Remember it died the other day?
Yeah.
Like, all right. Oh, well. That's okay. We were ready to quit anyway. Yeah, they're talking snow, right?
What did you think it was?
What's that?
What's that?
You can look on a different site if you want to. Is this weather.com?
Yeah.
All right, so we got 32 is the current temperature. The dew point temperature, yours says 34. Oh, we got a little warning up there. Did you see that, Des Moines?
Oh, there's a warning all over the place.
Okay. Well, this is kind of surprising to me. I thought it'd be closer than this. So the
And
current
humidity
temperature is
wasn't very high
32. Yeah, the dew point temperature is 11, so we need to go to 11 in order for condensation to begin. Yeah, the humidity, what did it say?
34%.
34%. Yeah.
They changed the warning.
What did they change it to?
Stew cumulating to 6 to 8 inches with winds gusting up to 20-25 miles an hour.
I'm not
Visibility,
listening.
half a mile.
I don't do snow. I don't do
I don't
ice.
do driving in it.
When is it going to come, Joe?
Let me go down. I'm sorry, I was reading
Yeah,
ahead.
the store.
Windstorm is moving Midwest tonight, up until 6 a.m. tonight, tomorrow morning.
Tomorrow morning.
Yeah. Anywhere after 2 p.m. today.
Well, I try to tell my, I have a 9 a.m. lab, so I try to tell those students, watch your email, because if I don't want to make it in, and they don't cancel, then I'm going to call in sick.
You drive in Burlington?
So, yeah, I live in Burlington, yeah.
Yeah, see, that's safe and sorry, you know. I mean,
Yeah,
come on.
I agree, so
I think we should.
they're pretty good about canceling anymore. So,
Sometimes.
yeah.
Sometimes.
Yeah.
I thought so far they have been pretty good about it.
Thanks for that good news, Joe. All right.
You're welcome.
I do want to get to this little part about snow. How appropriate, right? Oh my goodness. All right.
I think we should not talk about
It's a
snow.
favorite subject.
We jinxing us or what?
It's a favorite subject. Come on, who does not like snow?
I know. It's beautiful. I've seen some beautiful pictures.
Some of it can be beautiful.
So this isn't snow. This actually, those little, they don't look like snowflakes. Actually, those are little liquid droplets there. Yep. And this is kind of the assortment of sizes of little liquid droplets that are happening up in our cloud to make it milky white. Actually, I don't know if I'll convince you of this, but this assortment of sizes has to be there, because if it's not, we're not going to get anything large enough to fall from the cloud. So in order for raindrops to fall, you need this assortment. So to me, I usually, when I get ready to lecture, I always look at this, but actually this is the thing that falls from the cloud, kind of relative size-wise. Okay, so we have lots of tiny things up there, okay, and then the big one, generally, is kind of what we're looking at.
Do they come
Yeah, they do
together?
come together, do they? And we won't get to that until Monday, but we actually call this collision, and when it gets bigger, we call that, or as they merge, it's collision, and as they merge, coalescence. So collision coalescence is what we're going to talk about on Monday. But in the meantime, actually, we're going to focus on cold clouds. Cold clouds.
Ooh.
Yeah, I like what the video, this is the first, I've seen the video many times, but this is the first time I caught that it talked about those alto clouds. Actually, that's kind of in general, not now, right? But that's basically where kind of your liquid and your solid, that's kind of your freezing point. Right now, though, here in southeast Iowa, we have freezing here, okay? It only gets colder as you go up, as long as there's no temperature inversion. So there's this phenomenon called supercooled water. I'm going to play this video for you, and then we'll talk about it. Anytime in physical science that you run into the term super, okay, it means, super means it ought not be that way. So supercooled means it ought not to be a liquid at the cold temperature it is. Okay.
Ought not.
What's that?
I love that saying. Yeah, ought not.
It ought not.
I'm waiting for Mary Poppins to come through the door next.
Water. And then
It's the
open
same
it when
thing.
it does.
People were out partying and have beers and coolers and stuff like that. The bottle's sitting in there, take it out, pop it in the top of the beer.
I like
freezes
it.
over.
You kids, yeah. Yeah.
Had to use beer, I don't know why.
But just how that agitation to kind of make it go from a liquid to a solid. Picture basically your airplane flying through supercooled water. So basically it freezes on contact, which is not good. That's why they will have sprayed liquid on your plane wings before, I don't know much about this, but before you go up to basically prevent, or if it does freeze on contact, it doesn't stick. Crisco. No.
Same with people in the military, they use thermal suits to jump out of planes anything above 30,000 feet, so they don't get the contact freeze.
Yeah, don't want to come down a popsicle. Exactly. So we've been talking about saturation, and if this doesn't click for you, that's fine. I'm going to try to explain how little snow crystals grow, And there's a word for it, it's on the next slide, it starts with the letter B, it's called the Bergeron process. Bergeron, it's like French, I like it. But in order for ice crystals to grow, basically, this is what you're going to see on the next slide, it takes use of, or it makes use of. So if you already have a chunk of ice that's started, okay? And it is actually in the same environment as supercooled water. Basically, your environment, that chunk of ice is basically, with that water vapor that's there, is super saturated. I don't know if I'm saying that right. See this 100%, 105%? That is like it's ready to go ahead, and the ice cube is ready to get bigger. Ice is ready to get bigger. It's like extra saturated, where the water is just as saturated. I'll show you what this looks like. Again, then you read that word or not. So again, I usually just go with the Bergeron process. The Bergeron process is usually what my test question over snow is. Okay, I just want you to know that it's called Bergeron process. And I like the figure from your textbook that's going to kind of show you that here in a minute. Okay, so what you're going to see on the next figure is an ice crystal falling through supercooled water. Ice crystal solid, supercooled water is supercooled water, we just talked about. But with regard to the environment that they're all hanging out in, with regard to the water vapor, that ice is going to basically rob that water vapor because it's super saturated. The supercooled water, actually we're going to see, is going to give up more water. It's going to give more water vapor to it. Okay, so that's kind of how this works. We use the word deposition, and I don't know if you can see the word deposit in deposition, but that's kind of how your ice crystal grows. It's just amazing. The thing that we curse is so beautiful. It takes so long and beautifully formed up there, right? Anyway, all right. So here is the figure I've been talking about. The Bergeron process, again, that's basically what I want you to know. Sometimes I guess I would say, and on the review session I would catch this because I know the question by the time we have our review sessions. But sometimes I would want you to know that this has to do with supercooled water and an ice floating. Okay, so here we go. Here's your little baby snowflake, right? Solid, and it's basically super saturated. Those water vapors, see the red, those little Mickey Mouse water vapors running around? All right. So let a little time occur, or let that snowflake fall through, that ice crystal fall through these water vapor. Notice it gets larger, and what's happening to the supercooled liquid? It's getting smaller.
Freezes as soon as the ice crystals go through.
So the ice crystal falls, deposition occurs because it goes from a vapor, it basically builds their snowflake, and your supercooled water goes ahead and gives more liquid to the atmosphere. So then the third one looks like this. Is that not adorable?
So the supercooled water keeps giving up water molecules.
Yes, the supercooled
more
water
the ice
sublimation,
crystals
or not
can
be sublimation, just be evaporation.
Yeah.
Yeah.
Basically, this feeds the snow.
Mm-hmm. It feeds the snowflake. Yep. I agree. Okay. Okay, so just to kind of finish up, we'll finish up on this slide. So, haven't you ever kind of seen sometimes snowflakes don't look like individual snowflakes, they look like they're kind of ganged up? Okay.
Big fat snowflakes.
Yeah, what?
There always big fat snowflakes.
Yeah. Mm-hmm. Big fat snowflakes. Okay, they can get larger not just because of the Bergeron process, or also because of a term called accretion. So that's the last slide, and we'll pick up here with this next slide on Monday. Okay.
So, it's like
Thank you, you too.
No, we're praying for